Hello guys, and welcome back to our YouTube channel. In this video we are going to be tackling the inverse of a matrix, and this is a very important concept in matrices, and by the end of this lesson you'll be able to compute the inverse of a 2 by 2 matrix and a 3 by 3 matrix using the determinants and adjoints. And you also know how to check if your inverse is correct or not, since it has many steps. Okay, so let's start with the first case. Okay, so to find the inverse of a matrix, we denote it by a to the minus 1. So if you have a matrix A and you want to write its inverse, then you denote it as you denote it as a to the minus 1. So the inverse of a matrix A is equal to 1 all over the determinant of that matrix A times the adjoint of the matrix A. So this case, so there is a condition to this formula. So there is a condition. This formula applies when the determinant of A is not equal to 0. Because if it is equal to 0, then it would make the inverse undefined. Because 1 divided by 0 is undefined. Okay, so let's start small. Let's start by the inverse of a 2 by 2 matrix. So we have 2 by 2 matrices. So let's start with the first one. Okay, so if we have a matrix A, B, C, and D, then the inverse of that matrix A will be 1 divided by the determinant. So the determinant of this matrix is AD minus BC, and then multiplied by the adjoint. The adjoint is DA, then we'll have minus B minus C. So that is how we look for the inverse of a 2 by 2 matrix. So let us take an example to explain this further. So let's have a matrix A, which is 2, 3, 1, 4. So the inverse of this matrix, you write down the formula first to know which to do first. So we have the determinant of A times the adjoint of A. Okay, so now we take it step by step. We need to look for the determinant, we look for the adjoint, and then we put everything in the formula. So let's start by looking for the determinant of A. So the determinant of that matrix is simply 4 times 2 minus 3 times 1. So this is 8 minus 3, which is equal to 5. Okay, so that is the determinant of that matrix. So now let's look for the adjoint of the matrix. So the adjoint of this matrix is, we have 4. We interchange those at the diagonal and we change the signs of those which are not at the diagonal. So that is what we have. So that is the adjoint of that matrix. So now we put everything back into our formula. So finally, A inverse is equal to 1 on the determinant of A, which we have solved, and it is 5. All that times the adjoint. The adjoint is 4 minus 3 minus 1 on 2. So that is the inverse of this matrix. You can multiply by 1 on 5. Let me just do it. if you like, or you can leave it like that. So this is 4 on 5, minus 3 on 5, minus 1 on 5, and 2 on 5. So you can leave it like that or not. So this is the inverse of the matrix. So let's have another example. Let's have a matrix 1, 2, 3, and 5. So we write down the formula. The inverse of, let me change this matrix, should be B. You can give it any name, B, C, anything you like. So B inverse is 1 on the determinant of B times the adjoint of B. So we do it step by step. First, we look for the determinant of B. The determinant of B is simply 5 times 1 minus 3 times 2. So this gives 5 minus 6, which is minus 1. So the determinant is minus 1. And the adjoint of the matrix B, we interchange the numbers at the diagonal and we change the signs of those which are not at the diagonal. So that is the adjoint of that matrix. So finally, B inverse is equal to 1 on the determinant, which is still minus 1, times the adjoint, which is 5 minus 2 minus 3 and 1. So this is the inverse, but here it can easily be simplified, because here we have only 1 divided by minus 1. So all these will give minus 1. So this is minus 1 times 5 minus 2 minus 3, 1. So here it's a single number, so you can simply multiply it. But if it was a fraction, you can multiply or you can leave it like that. So now this gives, so B inverse is equal to minus 5, 2, 3, and minus 1. So we are just multiplying every element by minus 1. So that is the inverse. So now let's go to the inverse of a 3 by 3 matrix. So here we have 3 by 3 matrix. So the formula for a 3 by 3 matrix is the same, but it is longer. Since the adjoint, you need to go through the matrix of a cofactor and the determinant is long. So it's the same, the formula is the same, but the process is long. So let's have a matrix. Let's take an example. So we have a matrix B is equal to 1, 2, 3, 0, 1, 4, 5, 6, 0. Okay, so that is our matrix. Okay, so the first step, we compute, first step 1, we compute the determinant. So we need to find the determinant first. The second step, we compute the adjoint. And the third step, we divide the adjoint by the determinant. Okay, so these steps are very long. So when doing this, like when you want to look for the determinant, always find a row which has zeros in order to make things easier. So let's start with step 1. Let's start with step 1. Step 1 says compute its determinant. So its determinant, we use cofactor expansion. So this is our matrix: 1, 2, 3, 0, 1, 4, 5, 6, 0. So this is our matrix. So remember when looking for the determinant, always put this in your head: plus minus plus minus plus minus plus minus plus, to know which has which sign, to know which number has which sign. So now we need to take a row. But there are some rows which contain zeros. So let us take the rows which contain zeros to make everything easier. Okay, so we can take the second or the third, but I will choose to take the third row. So let's take this third row. Let's start with the first element, minus 0. This is in the position. 0 is in this position, so it's going to have minus. It is in that position, so it's going to have a minus sign. So we have 0 now times. Now we eliminate its rows and columns. Let's eliminate. So this is the 0 we are taking. So we'll eliminate this and eliminate that. So what are we left with? 2, 3, 6, and 0. So we write it down: 2, 3, 6, and 0. Now let us take the next number, 1. 1 has a positive sign, so plus 1. We eliminate again. We are left with 1, 3, 5, 0. We take the next, minus 4. We eliminate. We are left with 1, 2, 5, 6. So now we simplify this. So already 0 times anything is 0. So this now already gives us 0. So we just exclude that. So we just have 0 plus 1 times. Now we take the determinant of this 2 by 2. 1 times 0 minus 5 times 3. And then we have minus 4 into 6 times 1 minus 5 times 2. So this gives us 0 plus 1 into 0 minus 15 minus 4 into 6 minus 10. So this is 0 minus 15. Sorry, this is minus 4 now into 6 minus 10 minus 4. So this gives us minus 15 plus 16. So all this gives us 1. Minus 15 plus 16 gives us 1. Okay, so that is the determinant. So the determinant, what was the matrix? The matrix was B. So the determinant of B is 1. That is only for the determinant. So you see the steps are long. So that is why we need to look for a row which is 0 to make things shorter and easier. Now let us have step 2. Step 2, we need to compute the adjoint. Okay, so that is our matrix. Now we need to look for the matrix of the cofactor. So let me write back the matrix. Sorry, it's 1, 3, 0, 1, 4, 5, 6, 0. Okay, now let us look. This is our matrix B. Now we need to look for the matrix of a cofactor in order to find the adjoint. Remember, the adjoint of B is equal to the transpose of the matrix of cofactor. So that is the adjoint. So we need to look for the cofactor matrix and find its transpose. Okay, so to find the cofactor matrix, we write that 4 times. 1, 2, 3, 0, 1, 4, 5, 6, 0. 1, 2, 3, 0, 1, 4, 5, 6, 0. 1, 2, 3, 0, 1, 4, 5, 6, 0. 1, 2, 3, 0, 1, 4, 5, 6, 0. Now we eliminate the outer numbers. So we have that. Now let us have 2 by 2 matrices to find each element. So we take the first one. So this is 0 times 1 minus 6 times 4. That's the first element. We take the second 2 by 2. 5 times 4 minus 0. We take this third 6 times 0 minus 1 times 5. Now we go below. 3 times 6 minus 2 times 0. We take the next. Take this now. 1 times 0 minus 3 times 5. We take the next case. 2 times 5 minus 6 times 1. Okay, now we take the next. 2 times 4 minus 3 times 1. Take the next again. 0 times 3 minus 4 times 1. And we take the last. 1 times 1 minus 2 times 0. So this is what we have. Now let us simplify that. So we have 0 minus 24, 20 minus 0, 0 minus 5, 18 minus 0, 0 minus 15, 10 minus 6, 8 minus 3, 0 minus 4, 1 minus 0. This gives us minus 24, 20 minus 5, 18 minus 15, 4, 5 minus 4, and 1. Now that is our matrix of cofactor. So now let's take the transpose of that matrix to find the adjoint. So the adjoint of B is equal to, let's take the transpose of that matrix. So we switch, the row becomes the column. The first row, minus 24, 20, minus 5, 18, minus 15, 4, 5, minus 4, and 1. That is our adjoint. So altogether, the inverse of the matrix, so this is step 3, finally. The inverse, B inverse, equal to 1 divided by the determinant. What is the determinant of the matrix? The determinant was 1 divided by 1 into the adjoint, minus 24, 18, 5, 20, minus 15, minus 4, and minus 5, 4, 1. So this basically gives us the same thing. So this is 1 divided by 1, which is 1. And 1 times anything is the thing. So this is minus 24, 20, minus 5, 18, minus 15, 4, 5, minus 4, and 1. So finally, that is the inverse of the matrix B. Okay, so now let's go to another part, which is to verify the inverse. So once you've found an inverse, now how do you know it is correct? So now, if you multiply the original matrix you had with your inverse you have now, if you get the identity matrix, then that inverse was correct. So now we need to determine, so our original matrix, okay, so since we had B there, let me just say B. So B, if B times B inverse gives you the identity matrix of that matrix, then it is correct, then your inverse is correct. Okay, so that is that. Now let's test and see whether this inverse that we had is correct. Okay, so our original matrix was 1, 2, 3, 0, 1, 4, 5, 6, 0. This was our original matrix. And our B inverse, the inverse of that matrix was minus 24, 18, 5, 20, minus 15, minus 4, minus 5, 4, and 1. So what is the identity of a 3 by 3 matrix? It is simply 1 all through the leading diagonal. So the leading diagonals must be 1. So this is the identity matrix of a 3 by 3 matrix. So we have 1s at the leading diagonal. That's the identity matrix. So let's take B times B inverse and see whether it is going to give us an identity matrix. So we have 1, 2, 3, 0, 1, 4, 5, 6, 0 times minus 24, 18, 5, 20, minus 15, minus 4, minus 5, 4, and 1. So now let us multiply. So this will give 1 times minus 24 plus this 4 plus 2 times 20 plus 3 times minus 5 for the first 18 plus 2 into minus 15 plus 3 into 4. Second case, now third case, 5, that's 1 times 5 plus 2 into minus 4 plus 3 times 1, 3. Now we have 0 plus 20 plus 4 into minus 5, 0 plus 1 into minus 15 plus 4 into 4. 0 plus 1 into minus 4 plus 4. The third case, 5 into minus 24 plus 6 into 20 plus 0. 5 into 18 plus 6 into minus 15 plus 0. 5 into 5 plus 6 into minus 4 plus 0. Now let's simplify and see whether it will give us an identity matrix. So this is minus 24 plus 40 minus 15, 18 minus 30 plus 12, 5 minus 8 plus 3, 0 plus 20 minus 20, 0 minus 15 plus 16, 0 minus 4 plus 4, minus 120 plus 120 plus 0, 90 minus 90 plus 0, 25 minus 24 plus 0. So let's simplify. Minus 24 plus 40 minus 15. So minus 24 plus 40 is 16 minus 15. 18 minus 30 is minus 12 plus 12. 5 minus 8 is minus 3 plus 3. So we just exclude the 0. 20 minus 20 minus 15 plus 16 minus 4 plus 4 minus 120 plus 120, 90 minus 90, 25 minus 24. So this gives us finally 16 minus 15 is 1, minus 12 plus 12, 0, minus 3 plus 3, 0, 20 minus 20, 0, minus 15 plus 16, 1, minus 4 plus 4, 0, minus 120 plus 120, 0, 90 minus 90, 0, and 25 minus 24 is 1. So this is an identity matrix. This is the identity matrix of a 3 by 3 matrix. So this already tells us that the inverse that we had above is very correct. So this is how to verify whether the inverse of the matrix you have gotten is correct or not. So that is it. Remember, to find the inverse of a matrix, it is 1 divided by the determinant of that matrix multiplied by the adjoint of that matrix. So that is all for today, guys. Thanks for watching this video, and I'll see you guys in the next video.